before we do you guys have any questions about anything? So if you're not working on your homework assignments, be working on them. You should be wrapping up Matrix very soon if you haven't already. Your next homework assignment is out and available for you to start. Your next quiz is out and available for you to start. Hopefully there'll be more coming soon. So again, make sure that you're staying on top of everything. If you need help, you're struggling, make sure to come to office hours. Make sure that you're asking questions because I do want you to perform well. So last time we left off, we were still working on our vector class. We're more particularly working on the iterator part. So here we want to do operator plus plus so that we can move to the next element. Operator plus so we can move some number of elements into our vector. And we would probably want as a final thing a const t reference. Oops. Operator star. So this is how we're going to access the element that we're at inside of our iterator. So operator plus plus, how do we move to the next element, given that we do have a position variable? Just, pause plus plus, move to the next thing, right? And then we would return star this, right? Don't forget down here we have an integer keeping track of which element inside the vector that we're at. If we wanted to do operator plus, what we could do is easily create a copy. So we can have a const vector iterator copy, and we want a copy of ourselves. Then we plus copy, and then we can return, not plus plus copy. Copy dot pause plus equals amount. Return the copy. And then finally we have operator star, which is supposed to get an element that we're currently at inside the vector. So how would we do that? Right, we want to get whatever position that we're at, that element inside our vector. How do we do that? Well, that would just be, well, we're going to need to include include vector dot h, not up here. We included vector dot h down there so that we could then do return, right, vector dot at pause. Right, that would give us the element at the position that we're looking for. This is not correct because this should be a const t reference of vector, and then we need to template our for declaration. So it would be template type name t. And then, yeah, I agree that we need to change these. This needs to be a vector of t here, and a vector of t, which means we might need to go change these guys as well. Vector of t and a vector of t. Oh, this should be a const vector iterator of type t reference, and of type t here as well. Any questions about our iterator class? Yes. Yeah. Oh, this template right here is just the line right after. Yes, it's going to the line right after, which is the class declaration specifier. So just saying const vector iterator is templated. Any other questions? Okay, great. So yeah. I'm just saying that vector is templated over some type. This could be any variable I want here, or any name. It could be like blah 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 blah. It's just its type name is now blah 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 instead of t. I need to specify that something is templated if it's templated. So over here, our vector class is templated over some type. I'm using T here and here. I'm using T here and here to kind of like signify that they're going to be templated over the same type. But I need to say that this class vector is templated, because if you look back here, my vector class, it's templated, right? So this class that I'm forward declaring, I also need to specify that it is also templated. No. Again, this is just saying that it's just some type, right? Could be whatever, right? But notice that when I have a vector, a reference to a vector, it's the vector, its type right here is the same type that I am templating the iterator over. So if the iterator is templated over T, right, I have to have a reference to a vector of T. They have to be the same. They wouldn't be allowed to be exchanged. Any other questions? Okay, so then let's pop back over here. I think we finished everything in vector. We need begin and end. So we're going to need to do another forward declaration here of our templated class of the const vector iterator. So template type name T, and then over here const vector iterator. Oh, class, thank you. So again, I'm doing that forward declaration. And then notice that my pound include of const vector iterator, notice that it's after my class declaration. This is because I'm going to need the definition of the class to actually be able to create instances of it down here. But if I did the inclusions, both of them at the beginning, I'd end up with like this circular inclusion loop again, like we talked about before. If you really want to see that happening out, try moving the pound includes to the top of the file, both of them, and you'll see that it's going to stop working. You can also then try copying and pasting into a single file to see what it's actually going to look like. Because remember, pound include is just copy and paste. And then we do need our begin and end. So I'm going to return a const vector iterator of type T begin, and this one will be const, and a const vector iterator of type T end const. Oh, we do need one other thing back here in our iterator. We need equals equals and not equals. So bool operator equals equals a const vector iterator reference right hand side const, and then bool operator not equals const vector iterator reference. So for two iterators, yeah. I don't think so. Something happened back up here. What broke? Right. Yeah, so you can make equals equals return different things besides bool if you want to, but it'd be a bit non-standard. If you want to see that happening, you can actually look at the test cases for your current homework for matrix, and you can see that I define my operator equals equals to return like an assertion or like assertion success or result. I can't remember what the type is, but it's not bool. So for these two iterators to be equal, they need to be iterating over the same vector, right? So if the address of my vector doesn't equal the address of the right-hand side dot vector, right? They have to be iterating over the same object, return false. Else if, I guess we should probably go add one more thing. Why are you putting this up here? It's too high up. So here we can just return pause is less than 0 or pause is greater than or equal to vector dot size. Returns that cast to a bool star this. So the operator bool will return true if we're inbounds, and it will return false if the not will return false if we're out of bounds. So else if they're both out of bounds, so not this and not right hand side, return true. So if they're both out of bounds, we're going to consider these two iterators to be equal to each other, regardless of how they're out of bounds. And then else return pause equals right hand side. So if we're not over the same vector, right? If we're not iterating over the same vector, we're not equal. If we're both out of bounds, we're considered to be true regardless of how we're out of bounds. Otherwise, if we're both inbounds and iterating over the same vector, we have to be at the same position to be equal to each other. Any questions here? Hopefully that all makes sense. So then operator not equals, just return not star this equals right hand side. And then we can pop back over here to vector. So begin, we want to return a const iterator, yes, of type t over what? Over which vector? Ourselves. And what position should we start at? 0. Now over here we want to make another iterator over the end. We should be pointing to the end of who? Ourselves, right? This. And what should we put over here for our value to be out of bounds? Just size, because remember, we want to go 1 out of bounds, right? So if there was 3 elements, 0, 1, 2 are all fine, but 3 is out of bounds, right? The end is 1 past the end. That's how it's always going to be used. Just double check something. Yeah, okay. So now we've, yes? Why do these functions accept references?
Vector?
Oh, the iterator? Yes. I don't want to create a copy of the object. And notice it's const. I won't modify it either. Oh, here? This one?
Yeah.
So I'm not comparing references. What am I comparing? Addresses. Remember, the ampersand in front of a variable means the address of. The ampersand after a type declaration means reference to. The address of a reference is equivalent to the address of the object it refers to. So I'm making sure that both of these vectors are iterating over the same object. this is probably wrong. Like if iterators are over different objects, they aren't the same. If both iterators are out of bounds, they are the same. Oh, if I did without the ampersand, then it would call the vector equals equals operator, which we actually haven't defined one. Right? It would go look for an equals equals over here in our vector class because I'd be comparing two vectors to each other. Well, we could define it, right? And it's pretty easy to find an equals equals for ourselves, right? If each of the elements in the vectors are the same and the vectors are the same sizes, the vectors are equivalent, right? But again, that's not what we want for the iterator equality. They have to be iterating over the same object. But I would have to declare, like, you want me to do something like this, like I want a vector of type t pointer is equal, temp is equal to the address of vector, like this, and then make another one for the right-hand side temp, and then compare those two things together. It's going to be the same thing, right? This is what I assumed when you meant using the star, not doing this. So remember, the star and the ampersand are inverses of each other, right? They would cancel each other out, so I just end up back with vector again, not its address. Anything else? Okay, great. So we probably have successfully made our vector class, at least somewhat, right? So we can pound, we'll probably actually want that. We will also define over here in our vector class, pound include ostream. And then over here, T and std : ostream reference operator out std out, and then a const vector of t reference vector. Where does this even put things at? Why is this over here in the const vector iterator? Okay, let's stop putting it in the wrong spot, please. Okay, so how would I go out printing out each of the elements of the vector? Well, the space between them. Oh, that's easy. For const auto reference val in vector, right? Out val with a space after it. Then we return out the end. This now works because we have those two methods, begin and end, defined in our class. If we didn't have begin and end defined, I wouldn't be able to do this for each type of for loop. But because I have begin and end, wherever they were at, because I have begin and end, they're actually going to be allowed to be used for there. So we can now make our vector. So we can say pound, oops, up here, pound include vector.h with a. Then over here we could have like a vector of type int. Where do we define our? Maybe we call it v. Oh, we didn't make a no argument constructor. You should have that. Come on. A vector of t and our size should be 0. There we have that now, and then we could do something like for I equals 0, I less than 10, plus I, v dot push back I, and then we could see out v. And let's see if this works. Probably something's going to break. Oh, well, that's surprising. Seems to have worked, right? Everything printed out and everything's kind of nicely done. We could try doing something like our insert function, because we can see that pushback is working, like v dot insert the value 99, right, at position, say, 2. So let's see if that works. And hey, it's there. Anybody have any questions? Yes. Yes. So I was able to access back here in our operator pool function, our operator equals. I was able to access the vector over here because even though it's a private member of a const vector iterator of type T. And notice that I am inside a member method of my class. So I have access to the private members of any instance of that class inside of that member method. Any other questions? Everything making sense? Because you're doing something very, very similar for this for your next homework. I know I'm going extra fast today. So one other thing, notice that we only made a const vector iterator. We didn't make an iterator that can modify things. One of the annoying things about doing iterators is that a lot of times they're going to be identical to each other, like the const vector iterator and a vector iterator. The only difference would be, which we will write vector iterator in a second. So new C++ class, I want a vector header, create header only. A lot of the things that we would be doing would be identical for every single operation. We would just make 2 changes. One of the changes would be, since we need to be able to modify the elements contained inside of the vector, we would need to have a non-const reference because we need to be able to modify the elements that are inside the vector. The other thing that we would need is an additional operator star that also returned a non-const reference. That would be the difference. Everything else would be identical. So they're super duper annoying to write because you more or less copy and paste the entire contents of the other one together. But we could do a little bit of trickery to make our lives maybe a little bit simpler. So we are also templated, which is why we're doing everything in the header files. And so what I could do is I could include over here const vector iterator. And what I could have inside in my private section is I could have a const vector iterator, maybe it's called CVI, inside myself, right? And you're going to say that, const vector iterator of type T inside myself so that I'm able to just recall those functions that don't have to change on the const vector iterator. The other thing that I would need would be a vector of type T as well. And then over here, we're going to need to forward declare that class. So we're going to have more or less the same functions. So I'm going to copy all of these things that we have here. And I'm going to throw them over here inside of vector iterator. It'll be public. And these things now need to be changed to be vector iterators. But we'll see a little bit of magic going on here. Okay, so over here, when I'm given both the position of the vector, which, oops, is type, come on, change. Okay, over to you. These guys are no longer const references here. They're just regular references. And that's fine. I guess this one should have been technically const over here. Back here. This should be const. Okay, so what we can do is we can call our const, call it CVI, right? Our const vector iterator can take in the exact same things. It can take in the vector and the position, and then we can also make our vector equal to the vector that was given. So now we go and initialize our submember calling its constructor. And then over here, we forward it to our vector iterator of type T constructor that takes in as an argument vector and then as a pos 0. Pop back. So operator plus plus is fairly easy. All we do, again, we're going to return star this. But now we can do CVI dot operator plus plus. Vector iterator of type T. Thank you. These guys should be of type T. T. Were they not over here? Good. So over here, I can more or less just rely on my little CVI guide to do the stuff for me. Again, over here, we're still going to have to make a vector iterator of type T called copy, who's a copy of me. And then here we can still do copy dot CVI plus equals amount. And then we can return the copy. Operator star, just return star CVI. Yep, that'll work. Fine. Then over here, we're going to need another method, const, not const T reference, just a T reference operator star. This is the one that's going to allow for modifications. So one thing that we're going to need here is we're going to need access to the const vector iterator's position because he's actually keeping track of where we're at. But that method is not public, right? Pos is not public. So I have two options. I can either provide a getter for this, or I could make it my friend. So which do you guys want to do? Make it a friend? Write a public getter. This is one of those things that could maybe go either way. You might want to make it a friend so that people aren't exposed to the value, but the vector iterator is closely tied. Or you might decide that, hey, you know, people might just want to know what position this iterator is at, and they could be able to ask. I'm going to do the public method, the public getter for right now, because it'll be simpler. Because declaring friendship with templated classes is a little bit more complicated. So now over here, right, we could just say return our vector dot at cvi dot get pos. And we'll make this consistent. Operator equals equals. This is really easy. You can just say return my CVI is equal to the right hand sides dot CVI. I'm reusing those functions that I had before. Return my CVI doesn't equal the right hand side dot CVI. Come on, you can do it, computer. Almost there. Operator bool. What do you think? Yeah. Alt enter. Static cast to a bool CVI, right? And then over here, we could just say return not star this. So I'm able to reuse all of that code and then add in that one additional operator to get the non-const version, which saves a lot of rewriting of stuff. Does this make sense? Otherwise, I could have literally copy-pasted everything I had from the prior one into this one and just changed some of the constants. Now, back here in vector, we now need to forward declare one more guy. Why are you including this up here? It's not the right spot. Vector iterator. Sorry. Pound include vector iterator. And we are now going to have two more begin methods, but these are going to be non-const versions. So we have a vector iterator of type T begin, vector iterator of type T end. And these guys, they're not going to be very special. They're pretty much going to look exactly like the ones for the other ones. Let's start this 0. And then again, we can return star this and size. Any questions here? So now I could do things like this if I wanted to. After I print out V, I could say like something for auto reference val in V, val plus equals 10. And then we could print it out a second time. And this one will be using the not const iterator because we have to modify things. And so it'll call the non-const begin. And something broke. So where did we break at? Yeah, sure, that's fine. The contents. So we got this to print out. Then over here, we create a new vector iterator. So like if we just like, step over this line, so we should see that CVI is over our vector who has 11 elements, which makes sense. Current position is 0. And vector is that guy. So we go and we construct another vector iterator. And now we're over here. He's V, he's val. Val has 0, which makes sense. I'll have to go look into that later to see why it's broken. I don't have time now in class to get what's up. Somewhere it looks like it's calling. Oh, I think I know what happened. Because this should have been a vector T reference. Let's try again. There we go. Problem solved. And if you're curious, how the hell did I know that? Well, that was probably the problem. I saw that the destructor was being called, right? And I'm like, the destructor should not have been called at this point because I have not reached the end of the program. But I could see that for whatever reason we were deleting the thing. So now we have the ability to actually modify our elements as we iterate through them. And you could also be explicit when you say like, I want a, iterator equals begin. Iterator equals end. Sometimes you might also find that you might have like the const iterators, right? So that you can be explicit about which of the two that you're going to get. So you might have like a const vector iterator of type T, C begin, const, and a const vector iterator of type T, C end, const. And then if we go and generate these definitions, and we want to throw them at the bottom of our class, please. So there could be different ways that we could do this. Probably a little bit easier way to understand is for when we have our begin and our end. Right here, this could be return our constant vector iterator. And then back here, we could just say, for begin, what could we say to return instead? We'll just C begin. Return whatever C begin returns. So that we're able to, because this is the const version of begin, so return whatever const begin returns. And then we could do the exact same thing for the end. Let's deal, should we start this? And then over here we have a size. And then over here for our const begin, we can return a const end. Yes? That's fine if its declaration comes afterwards. There's no problem. Because again, they're all declared at the top, right? And as long as you declare it at the beginning, right, the definitions can come in any order. Sometimes, so I'm implementing it the way that the vector class has it done. Sometimes you want to be explicit about what type of iterator you're getting, right? A constant iterator versus a non-const iterator. And so you can use C begin to make sure that you always get the non-const or get the const iterator. There are other times though when you want to use that for each loop, right? And that for each loop that we have back here is always going to call begin, right? So which begin am I going to call over here on line 15? Which begin and which end? The const or the non-const? Non-const, how do you know? Okay, but because I'm modifying it, but let's say, you could not see this line, right? It's gone. Const or non-const iterator? Can. There's no const here, right? If we go back over here to the vector when we did the O stream, wherever that guy's at, I used const, right? I also have the const over here on the vector, so it can only call the const methods. That's kind of how I know what I'm getting, but you need to be able to use it in kind of like either context. That's why I have both the const version and the non-const version of begin. But sometimes I want to explicitly get the non-const version, so that's why I also have C begin. How many of you guys have started using Git? Practice with it. It's going to make your life a lot easier, I promise. There are ways that I can force you to use it. Don't make me, but maybe I'll still have to for your next set of homework assignments where you'll only be able to submit via Git. So added in iterators. Okay. Next order of topics is there's a thing called smart pointers. So one of the biggest mistakes that people make when you're working with pointers is they forget to delete the space that they've dynamically allocated. It's super duper common, happens all the time, and it's a really easy mistake to make. So smart pointers were created to help alleviate this mistake. They're managed pointers, and what they're going to do is they're going to manage the lifetime of the object that they point to. When the pointer gets deleted, the thing that they point to also gets deleted as well. Does that make sense? So the smart pointers, they own whatever they point to. So if you're ever creating data using like new or delete, and you're supposed to be owning that data instead, like I have ownership over this, when I die, this thing dies too, you're going to want to be using the smart pointers instead, because then you won't have to worry about deallocating the space. You might also have a question of when should we use normal pointers, when should we use smart pointers? Smart pointers are again for asserting ownership over some object. If you own the thing, use a smart pointer to the thing. Use normal pointers when you just want to create a reference to that object, but have no ownership over it. You're not responsible for deleting it. Right? So if you have to delete it, smart pointer. You don't have to delete it, dumb pointer. Again, you might also be like, well, again, pointers, references. Again, if you're just working with the value and you don't care like where in memory that thing is at, accept a reference to the thing, then modify it. Right? If you actually need to be working with the pointer because you need to change where that pointer points to, or like deallocate the space, then that's when you would start using the pointer. Again, pointers would also need for when you need nullability or be able to move things around. But if you're just trying to like pass a value, a reference is going to be a lot easier way to do it. So there are three different types of smart pointers. There's unique, shared, and weak. The unique is for when one person owns that object. Shared is when that object is owned by multiple different parties. And weak pointers are for when somebody wants to refer to something owned by a shared pointer, but not include itself in the ownership of that object. So I might want to be able to use it, but I'm not responsible for deleting it. If you want to be able to use any of these smart pointers, you have to include memory. The unique pointer is the one that it's probably going to be the only one that you use in the class. It's the most common one. And with a unique pointer is used when that pointer solely owns the data that it points to, right? That one person, he owns it, he should be the one that deletes it. Ideally, nothing else should point to this pointer or point to where this pointer points at, but it can happen sometimes. But again, only use dumb pointers then to point to it, and make sure none of those dumb pointers delete the thing. If they delete the thing, everything's going to get screwed up. Again, if you only need to pass the value that that shared pointer points to, just pass the value. Don't pass the entire shared pointer. Nobody else needs the shared pointer if they just need the value. Pass the value instead. So if you want to create a unique pointer, the type declaration would be std : unique pointer to some type. If you create a pointer this way, it's going to point to nothing, to null pointer. If you want to create space, instead of using new, you should use make unique. So it's std make unique type. What's the thing that you're trying to create? And then the arguments to the constructor of that type. So it'll create, it'll pass those arguments to that constructor to create an instance of that type. So over here, right, I have a unique pointer to an integer called np. He's not pointing to anything. If I want to make a unique pointer, I say make unique int, and then the value that I'm passing to the integer constructor is the value 5. So I'm going to make a unique integer. I'm going to make an integer that has the value 5, and then int pointer is going to be the unique pointer to it. If we wanted to make a unique pointer to a vector that had 7 with 7 tens in it, right? Again, auto vec pointer. I make a unique vector to integers, right? I want 10 elements, each initialized to the value 7. So I think those two things are backwards. It should be with 10 sevens. Any questions so far? Okay, so again, make unique as opposed to new to create the space. If you want to dereference a unique pointer, you do it just like any other pointer. It's not special, so it has star and arrow defined on it. So again, if I make a unique integer, again, initialize to the value 5. If I do star int pointer, I get the 5. If I do star int pointer equals 7, I'm going to change the value at that location of memory to a 7 instead. If I make a unique pointer to a string called hello, and I ask for that string pointer arrow size, it's 5, because there's 5 letters in hello. Yeah. Why do I use auto? Because I didn't want to type out std : unique pointer to an integer. Just a lot shorter to write. Agreed? Well, the type of the unique pointer here is known. It's a unique pointer to a string. This is a unique pointer to an integer. Remember, the auto has to be deduced to a type, right? It's just not like magic happens. The compiler figures out what the type is supposed to be. And if I make a unique pointer to an integer, my type has to be unique pointer to an integer. If I make a unique pointer to a string, it has to be unique pointer to a string. I just didn't feel like typing out type here, so I just used auto instead. Does that make sense? So there are some additional operations that are defined on unique pointers. One is reset. What reset will do is it will delete whatever that unique pointer points to. You can also put in a new pointer as well, and then that unique pointer will delete whatever it points to, if it was pointing to something, and then it will then take ownership over that pointer that you passed in. You can use release to give up ownership over that pointer, but not delete it. So you're no longer going to be responsible for deleting this thing, and it's going to return back that raw, that dumb pointer, back to that object. So now you're responsible, whoever gets this pointer, to delete it later on. You can also use swap with another unique pointer, and what will happen is you'll exchange ownership over the objects that you own, right? So they'll own the other thing. So over here, P1 is a unique pointer to an integer that's the value 5. P2 is a unique pointer to an integer that has the value 10. If I do P1.swap P2, right, P1 now owns the 10, and P2 now owns the 5. If I do manual equals P1.release, this means that P1 is no longer responsible for deleting whatever it points to, which in this case would be the 10, right? And I'm going to get a dumb pointer back to that location. So manual is now a pointer to this 10, wherever it happens to be in memory. I then have to make sure that somewhere along the lines, I delete it before my program ends. So I can say delete manual to go free up that space. Or again, I can use it wherever I feel like. Over here, I do P2.reset. This is going to delete whatever P2 is now pointing to. And since I didn't pass in a pointer, I'm not going to take ownership over anything new. So I'm going to point to null pointer. Any questions here? Okay, we will wrap up smart pointers on Wednesday, and then we'll also get to like the most important thing in object-oriented programming. So make sure you come to lecture because it's really important. It's polymorphism and inheritance.